So good morning once again. Today we are going to do for class 9 and the topic will be law of motion. In the previous class we learned about force. So briefly let's recap with this one. Force, what is force? Force is a push or pull of an object. So there are 6 types of force, namely number 1 is muscular, 2 frictional, 3 magnetic, 4 gravitational, 5 electrical, and 6 electromagnetic force. So there are 2 types that we have learned, that is balanced and unbalanced force. The balanced force produces no acceleration on it, whereas unbalanced force produces an acceleration in the direction of the force of greater magnitude of the body. So today we are going to learn about Newton's law of motion. And the first law of motion states that every body continues in its state of rest or of uniform motion in a straight line, unless compelled to change that state by an external unbalanced force. This means that an inanimate object cannot alter its own motion or its state of rest unless a force is applied. So this property is also known as inertia. So Newton's first law is also known as a law of inertia. For example, while traveling in a vehicle, if the driver applied a braking force, our body tend to continue in the same state of motion. Or another example, in shooting an arrow from a bow, the string applied a force, and as soon as the arrow leaves the string, it continues in a uniform motion. So this is due to the property of inertia. So an external force is needed to change the motion. And second law, Newton's second law of motion statement. It states that the rate of change of momentum of a body is proportional to the applied unbalanced force in the direction of force. So there is P is equal to mv, where P represents momentum, m as mass of an object, and v a velocity. For example, let me give you one example. When an athlete participating in a high jump are made to fall either on a thick cushion of bones or on a sandbag. This is to increase the time of the person falls to stop after the jump. So as a result, the rate of change of momentum is decreased. This means that force is directly proportional to the rate of change of momentum. So like here, just now we talk about momentum. So what is meant by momentum? The quantity of motion of a body measured as a product of its mass and velocity is known as momentum. So the momentum P is measured by the product of the mass m of the body and its velocity v. So this is we can represent as P is equal to mv or F is equal to ma. And for this, we need to represent this mathematical formation of Newton's second law of motion. So suppose an object of mass m and initial momentum pi equal to mu, and final momentum after time t is pf, that is mv. So then the change in momentum will be pf, that is final momentum minus initial momentum. As given in this picture, you can see it, mv minus mu. The rate of change of momentum is m whole v minus u by time. So for by applying force, F proportional m v minus u whole by t. So F is equal to km v minus u by t. That is kma, or F is equal to ma, where a is equal to v minus u by t, which is the acceleration, the rate of change of velocity, and k is a constant of proportionality. The SI unit of mass and acceleration are kg and meter per second square. So accordingly, one unit force is defined as the amount produced and acceleration of 1 meter per second square in an object of mass 1 kg. There is one unit of force is equal to constant 1 kg into 1 meter per second square. So thus the value of k become 1. Therefore, F is equal to mass into acceleration. Let's go to the next law, there is third law, Newton third law of motion statement. To every action, there is an equal and opposite reaction. For example, the force exerted by balance A and balance B is called the action, while the force exerted by balance B on A is called reaction. The two forces are equal in magnitude but opposite in direction. Or let me give you another example to understand it more clearly. Let's say when a gun is fired, it exerts a forward force on the bullet at the same time. The bullet exerted an equal and opposite reaction force on the gun. Let's go to the next. Conservation of momentum. So the law of conservation of momentum states that when two bodies collide with each other in the absence of an external force, then the total final momentum of the body is equal to their initial momentum. That is, momentum is neither created nor destroyed, but only changed through the action of force. So let's derive the formula of conservation of momentum. Let force of an object 1, that is mass m1 and acceleration a1, then force equal to m1 a1, that is where a is equal to v1 minus u1, that is final momentum minus initial momentum. And let's take another object, that is object 2, where mass is m2 and acceleration is a2. Then the force is equal to m2 a2. So from this third law, force exerted by object 1 is equal to force exerted by object 2. That is m1, force from B to A equal to m2 into a2, that is m2 whole final momentum minus initial momentum by t. And the force from object A to B is equal to m1 into a1, that is m1 whole final momentum 1 minus initial momentum 1 divided by time. So from these two formula, we can derive that m2 whole v2 minus u2 by t is equal to minus m1 v1 minus u1 whole t. Since here there is a negative sign, since it is an opposite in opposite direction. So from this we can derive that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is final momentum of second object equal to original momentum of second object. Thus, momentum is conserved. So let me give you one example for this conservation of momentum. So like in a rocket, the basic working principle of toy rocket is based on Newton's third law of motion as well as the principle of conservation of momentum. So in this case, the hot gas produced by rapid burning of fuel rushes out as a jet at the bottom, an opposite reaction. The force of the downward going gas pushes the rocket upward with a great speed. Here, the momentum of the rocket is equal to that of the hot gas. For your assignment, I'll give you some question for home assignment. So number 1, define 1 Newton of force. Number 2, why does the striker move through longer distance when some powder is sprinkled on a carom board? Number 3, explain Newton's law of motion with example. And number 4, derive or write the mathematical formation of Newton's second law. And number 5, define conservation of momentum and show it with a suitable mathematical example. So hope to see you again.